The topic of our video is concentration of solution. Before we discuss concentration, we should know what is a solution. A solution is a homogeneous mixture of two or more substances mixed in any proportion. Usually a solution is either formed between a solid and a liquid or between two liquids. If the solution is formed between a solid and a liquid, then the solid is taken as solute and the liquid is taken as solvent. However, in case the solution is between two liquids, then the liquid in lesser quantity is known as solute and the liquid which is in more quantity, that is taken as the solvent. Now by concentration we mean how much solute has been dissolved in a fixed quantity of the solvent. If the solute is in more quantity, then the solution is known as concentrated, and if the solvent is in a more quantity, then that is known as a dilute solution. Now, although there are many methods to express the concentration of a solution, widely used methods are molarity, molality, and mole fraction, which we are going to discuss. So first of all, we will discuss molarity, which is denoted by capital M. And molarity is defined as the total number of the moles of solute dissolved in a given volume of solution, provided the volume of the solution is in liter. So from the definition we are seeing that there is number of moles. So how will you calculate the number of moles? We can calculate the number of moles of the solute by using the relation number of moles is equal to given mass upon molecular mass. The given mass is denoted by small w and the molecular mass is denoted by capital M. Once we know the number of moles, we can divide by the volume in liters, so we will get the molarity of the solution. We can take an example to explain it. Suppose we are taking 49 grams of sulfuric acid and we are dissolving it in 500 ml of solution. Then if you want to calculate the molarity, first of all we will have to calculate the number of moles, which can be calculated by the formula given mass upon molecular mass. The given mass is already there, 49 grams. So we will have to calculate now the molecular mass of sulfuric acid. Since its molecular formula is H2SO4 and we know the atomic weight of hydrogen is 1, sulfur is 32, oxygen is 16, so that will come out to be 1 into 2 plus 32 plus 16 into 4, which is 98. Now the number of moles will be, given mass is 49 and molecular mass is 98, so 49 by 98 is 1 upon 2, that is 0.5. Volume of the solution is given to us 500 ml. If we have to convert it into liter, we will divide it by 1000. So that will also be 0.5 liter. So molarity will become 0.5 upon 0.5, that is 1 m. So our solution is 1 molar solution. Then the second method which is used is molality. Molality is denoted by small m. And molality is defined as the total number of the moles of solute in 1 kilogram of the solvent. So the formula for molality is number of moles of solute upon mass of solvent in kilogram. So the basic difference between molality and molarity is that in molality there is mass of the solvent in kg in the denominator, while in molarity there was volume of the solution in liter in the denominator. Now with the change in temperature, there is no change in the mass, however there is a change in volume. So the molarity will change with temperature while molality does not change with temperature. Now the third method to express the concentration is mole fraction. The mole fraction is defined as the ratio of the total number of moles of a component in the solution to the total number of moles of all the components in the solution. So suppose there are two substances A and B and we are mixing it to form a solution. Then the mole fraction of A will become, if we are denoting it by XA, that will become XA is equal to Na upon Na plus Nb, where Na denotes the number of moles of A, Nb denotes the number of moles of B. So XA is equal to Na upon Na plus Nb. Similarly, if we want to find the mole fraction of B, that will be Xb is equal to Nb upon Na plus Nb. Now, if we are mixing two components to form a solution, or we are mixing more than two components to form a solution, the sum of the mole fraction of all the components will always be 1. Now let us take an example to explain the mole fraction. Suppose we take 73 gram of HCl and we are dissolving it in 36 gram of water. And we have to find the mole fraction of both HCl and water. If I assume HCl to be A and water to be B, first of all I will have to find the number of moles of A, that is HCl. Now we know the formula for number of moles is mass upon molecular mass. So that will become WA upon MA. WA stands for the mass of A, MA stands for the molecular mass of A. The mass of A, that is HCl, is given to us 73, so we will substitute WA as 73. Now molecular weight of HCl is the sum of the atomic mass of H and Cl. Since the atomic mass of H is 1 and that of Cl is 35.5, so that will be 1 plus 35.5, that is 36.5. So the number of moles of A will become 73 divided by 36.5, that will come out to be 2. Similarly, we can find the number of moles of B, that is water. That will be WB upon MB. Mass of water is given to us, that is 36 gram. Now we'll find the molecular mass of water. Since the molecular formula of water is H2O and the atomic mass of hydrogen and oxygen are 1 and 16 respectively. So that will become 1 into 2 plus 16, that is 18. So now the number of moles of B can also be calculated. The given mass is 36, molecular mass is 18. So 36 upon 18 will become 2. So Na is also 2 and Nb is also 2. Now Xa will become Na upon Na plus Nb. That is 2 upon 2 plus 2. It will come out to be 2 upon 4 or 1 upon 2. Similarly, we can find Xb by using the formula Nb upon Na plus Nb. Again, Nb is 2. Na and Nb are also 2 and 2. So that will become 2 upon 4, that is half. So the mole fraction of A as well as B is 1 by 2 or 0.5. We can also calculate the mole fraction of B simply by using the fact that the sum of the mole fractions of A and B will be 1. Since Xa we have already calculated as half, so half plus Xb will become 1. Xb will become half.